Understanding estimators and confidence intervals. Let's start with the basics: populations and samples, an essential concept in statistics. Parameters are values from the entire population, while statistics are estimates from samples. Think of a population as a big bucket and the sample as a cup taken from it. A point estimate is a single value that serves as an estimate of a population parameter. For instance, the sample mean is the average temperature calculated from sample data. Now let's learn about the margin of error, the expected difference from the true parameter. Margin of error depends on confidence level, sample size, and data variability. Let's look at how to calculate the margin of error using temperature data as an example. Step 1. Identify sample size. Step 2. Calculate the standard deviation. Step 3. Plug values into the margin of error formula to find E. Next, let's define confidence intervals and their purpose in estimating means. Confidence intervals estimate the range within which the true mean lies with a certain confidence. Use Z-distribution for larger samples, or when sigma is known, use T-distribution for smaller samples. Let's break down the steps. Identify sample mean, choose confidence level, calculate E. For example, let's calculate a confidence interval based on apartment rent data. Calculate our margin of error and adjust our sample mean to form the interval. Here's a handy table to understand how different confidence levels affect critical values. Now, let's explore point and interval estimates specifically for population proportions. The point estimate for a proportion is calculated as the number of successes over total trials. Don't forget, the complementary proportion is simply 1 minus the point estimate. To construct a confidence interval for a proportion, we use a similar approach that includes E. The margin of error here is E equals Z opening parentheses C closing parentheses times P1 minus P/N. Let's calculate the point estimate using survey results, like 320 successes out of 400. Here we interpret our interval results, with insights on the population's characteristics. Finally, let's emphasize the differences between dealing with means and proportions. Means deal in averages while proportions focus on successes over total trials. To summarize, understanding estimators, margins, and confidence intervals is vital in statistics. Review some key formulas and definitions for a smooth journey through statistics. Collaborative practice can enhance understanding and retention of statistical concepts. Utilize study resources and practice problems for comprehensive learning on these topics. Embrace statistics and apply these concepts to real-world scenarios confidently.